Hi, fifth graders, and welcome back to another math lesson. For today's lesson, all you will need is a dry erase marker and some form of a dry erase board. And if you don't have that, a pencil and paper will work as well. Are you all ready to get into today's lesson? All right, let's go. Your learning target for today is I can solve single-step and multi-step practical problems involving adding and subtracting fractions and mixed numbers using the standard algorithm and tape diagrams. So again, you're working on fraction word problems that involve adding and subtracting. Today, we're going to practice using the standard algorithm. So that means just using the numbers, and we're going to practice again with tape diagrams. Let's take a look at problem number 1. It reads, Sandy ate 1/6 of a candy bar. John ate 3/4 of it. How much more of the candy bar did John eat than Sandy? All right, so what I'm going to do to start off with this problem is I'm going to actually make an area model. I'm going to make the first one and I'm going to divide it up into fourths because I know that John ate 3/4. And I'm going to make a second tape or area model rather, and I'm going to divide that up into 6 because I know that Sandy ate 1/6. So for John, I can shade in 3 out of the 4 pieces. And for Sandy, I'm going to shade in 1 out of the 6 pieces. So from looking at this area model, I can see that 3/4 is larger than 1/6. And that's going to help me out when it comes to making my tape diagrams. So I'm going to leave this over here on the side as a reminder for me that 3/4 is larger than 1/6. Another way I could think about that is, I know that 3/4 is greater than 1/2 if the 1/2 line is here, whereas 1/6 is less than 1/2. So I do know that 3/4 is larger than 1/2, and that's going to, or 3/4 is larger than 1/6, I'm sorry. And that's going to help me when it comes to making my tape diagram. So the first tape diagram I can make is for John. Then I can make a second tape diagram for Sandy, but I know that her bar needs to be smaller. Go ahead and on your paper or on your dry erase board, make a tape diagram for John, and you know that that tape diagram needs to be longer than Sandy's tape diagram because 1/6 is less than 3/4. All right, after I do that, the problem is asking me how much more of the candy bar did John eat? Well, if I want to know how much more, what I'm really looking to find in this problem is this part that is different from John's bar. If Sandy's bar is here and John's bar stops here, Sandy's bar is how, or John's bar is how much more than Sandy's bar. And that's really what I'm trying to figure out for this problem. So, knowing that, what operation do you think we're going to use for this problem? How am I going to find out what this piece here equals? If you said subtraction, you're right. I know that this bar is worth 3/4. I know that this bar is worth 1/6. So if I want to figure out what this missing bar is worth, I know that I need to take 3/4, or take 1/6 rather, and subtract that from 3/4. All right, now when I subtract 3/4 minus 1/6, I can't subtract straight across there because my denominators are not the same. So I need to make my denominators the same first. And I can do that by finding the least common multiple between 4 and 6. I need to find a common denominator between these two fractions. So I can start listing my multiples of 4 first. So I'm starting with 4. Then I know after 4 comes 8, 12, 16. All right, now I'm going to start listing my multiples of 6. I know that I have 6 and 12. Once I get to 12, I'm going to stop because I know that I found the least common multiple, which means my least common denominator for this problem is going to be 12. So I now need to take 3/4 and multiply this fraction, multiply my denominator by what, so that it can have a denominator of 12. 4 times what would give me 12? If you said 3, you're right. 4 times 3 would give me 12. And whatever I do to the bottom, my denominator, I have to do to the top, my numerator. So 4 times 3 is 12. 3 times 3 is 9. So I now know that 3/4 is equivalent to 9/12. Now, 9/12 is good, but I still have to worry about 1/6. I need to change this fraction so that it also has a denominator of 12. So what can I do to 6 to make it so that it has a denominator of 12? What can I multiply 6 by to get to 12? You've got it, 2. 6 times 2 will give me 12, and whatever I do to the bottom, my denominator, I have to do to the top, my numerator. So I need to multiply the numerator and the denominator by 2, and that will give me 2/12. So I know that 1/6 is equivalent to 2/12. Now that my denominators are the same, now I can subtract like normal. 9/12 minus 2/12, 9 minus 2 is 7. So my answer here is 7/12. Now, before I confirm that answer, I need to do a simplified check, which means I need to see if this fraction can be simplified. So let's check and see if we can simplify 7/12.
Okay, so I want to see if I can simplify 7/12. To do that, I need to find the greatest common factor, or GCF, of 7 and 12. To do that, I need to first find my factors for 7. I know that my factors for 7 are 1 and 7, and I can check that by saying 1 times 7 is 7. Then I need to find my factors for 12. I know that my factors for 12 are 1 and 12, 2 and 6, and 3 and 4. I can check that by saying that 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. Now that I've listed both my factors for 7 and 12, I need to find the greatest common factor. In this case, there's only one common factor, which is 1. To simplify a fraction, I need to divide my numerator and my denominator by my greatest common factor. But in this case, it's 1. So if I divide my numerator by 1 and my denominator by 1, my fraction would be the same, meaning I can't simplify 7/12 any further.
All right, jumping into problem 2. It reads, Jackie brought 3/4 of a gallon of iced tea to the party. Bill brought 7/8 of a gallon of iced tea to the same party. How much iced tea did Jackie and Bill bring to the party? Okay, so again, I want to make a tape diagram for this problem. When I make my tape diagram, and when you make yours on your paper or dry erase board, go ahead and do that now. But we know that it needs 2 sections in this tape diagram. 1 section for Jackie, and then 1 section for Bill. I know that Jackie's section represents 3/4 because she bought 3/4 of a gallon of iced tea. And I know that Bill's section represents 7/8 because he bought 7/8 of a gallon of iced tea. Now, what I'm looking to find is how much iced tea did both Jackie and Bill bring to the party. So looking at this tape diagram, I hope it helps you understand the problem. What operation do you think we're going to need to use this time? If you said addition, you're right. I need to add 3/4 plus 7/8 to figure out what is the total length of this bar, or how much would this bar represent in this case. Now, when looking at 3/4 plus 7/8, again, I can't just add straight across because my denominators are not the same. I need to make it so that I have common denominators so I can add these fractions together. And to do that, again, we need to find the least common multiple so we know what to turn these denominators into. What's the least common denominator that these fractions could have? So I need to find my least common multiple of both 4 and 8. So I'm going to start listing my multiples for 4. I have 4, and then next is 8. Now, I'm going to automatically stop right there because I've already found a match. I have 4 and 8, and my other number is 8. So I've already found that my least common multiple is 4. I'm sorry, 8. So that means that I need to make sure that both of these fractions have a denominator of 8. 7/8 already has a denominator of 8. So there's nothing that I need to do to change that fraction. But I can rename 3/4 by multiplying my denominator of 4 times what would give me 8. If you said 2, you're right. I can take 4 times 2, and whatever I do to the bottom, I have to do to the top. Whatever I do to my denominator, I have to do to my numerator. So 4 times 2 is 8, 3 times 2 is 6. So I know that 3/4 is equivalent to 6/8. Now that my denominators are the same, now I know that I can add these two fractions together. 6/8 plus 7/8 would give me 13/8. Now, 13/8, we call this an improper fraction. Any ideas on why we call that an improper fraction? All right, the answer is we call this an improper fraction because my numerator is larger than my denominator. And when that's the case, you would call that fraction an improper fraction. So I want to take this improper fraction and I want to turn it into a mixed number. A mixed number is when I have both a whole number and a fraction. And I like to turn my improper fractions into mixed numbers by using a number bond. So to do that, I know that in 13/8, there is one whole in 13/8, and that's 8/8. So 8/8, that part makes up one whole. So I took out one whole from that 13/8. And that leaves how many eighths would be left? Now, to do this, you have to think 8 plus what would give me that 13. So there's 5/8 left. So I can rename 13/8 as 8/8 and 5/8. And that helps me because I know that the mixed number would be 1 and 5/8. So my answer for this problem is 1 and 5/8. Now, before I confirm that as my final answer, I need to do a simplified check. I need to check and see, can this fraction be simplified any further before I move on to the next problem? So let's check and see.
I'm now checking to see if I can simplify 1 and 5/8. To do this again, you need to find the greatest common factor of 5 and 8. When I list my factors for 5, I know that they are 1 and 5, because 1 times 5 is 5. Next, I'm going to list my factors for 8, which are 1 and 8, and 2 and 4. Next, you go through and you see if there is a greatest common factor. In this case, I only have one common factor, which is 1, which means that 1 and 5/8 cannot be simplified further.
Okay, jumping into problem 3 now. It reads, Angela practiced piano for 2.5 hours on Friday, 2 1/3 hours on Saturday, and 3 2/3 hours on Sunday. How much time did Angela practice piano during the weekend? So for this problem, on your paper or on your dry erase board, I want you to make a tape diagram, and I want you to divide it up into 3 sections. We're going to divide it up into 3 sections because we're representing time here for 3 days, Friday, Saturday, and then Sunday. So this first section of my bar is going to represent Friday, in which Angela spent 2.5 hours or 2.5 hours practicing the piano. For the next bar, that's going to represent Saturday, which is 2 1/3. Then your last bar is going to represent Sunday, which is 3 2/3. Now, hopefully by looking at this on a tape diagram, it helps me to see what operation I need to use for this problem. I'm trying to figure out how much time Angela spent on all 3 of these days combined. So what operation would I need to use for this problem? If you said addition, you're right. Great job. I need to add 2 1/2 plus 2 1/3 plus 3 2/3. Now, I cannot just zoom through this problem and start adding yet because my denominators are not the same. So I need to make my denominators the same. Even when I'm adding 3 fractions or 3 mixed numbers, that still applies. So I'm looking at my denominators for these 3 mixed numbers, and I see that I have a 2, a 3, and a 3. So I need to find the least common multiple then of both 2 and 3. So I'm going to start listing my multiples of 2. I have 2, you can call them out with me, 4, 6, 8, and I'm going to stop there. Now I'm going to list my multiples of 3. I have 3, 6, and I can already stop. Why can I stop? Because I've already found a match. 6 is my least common multiple. And I know that if 6 is my least common multiple, then that's my least common denominator for these 3 mixed numbers. So I'm starting with the first one, 2 1/2. What can I do to 1/2 to make it so that this 2 is a 6? How can I turn my denominator of 2 into a denominator of 6? Well, I can multiply by 3. 2 times 3 is 6, and whatever I do to the bottom, I have to do to the top. Meaning, whatever you do to the denominator, you have to do to the numerator. So 2 1/2 is going to be equivalent to 2 3 6. Those 2 fractions are equivalent. And I know that, right? We know that 3 is half of 6, just like 1 is half of 2. All right, moving on to the next fraction. I want to now take this denominator and make it so that it is 6. I can do that by multiplying by 2. 3 times 2 is 6, and whatever I do to the bottom, I have to do to the top. So 1 times 2 is 2. So 2 1/3 is equivalent to 2 2 6. Now, if I multiply by 2 with this fraction, I know that this one also has a denominator of 3. So again, that number is going to be 2. So 3 times 2 is 6. 2 times 2 is 4. 3 2/3 is equivalent to 3 4 6. Now that all my denominators are 6, now I can add these mixed numbers together. Starting with my whole numbers, I know that 2 plus 2 plus 3 is 7. And then I know that 3 6 plus 2 6 plus 4 6 will give me 9 6. So I now know that this is worth, or that these 3 sections represent 7 9 6. Now, I do have an improper fraction in there. So I want to rename that 9 6 as 6 6, and I would have 3 6 left over. So that's the same as 1 3 6. That 1 I could add to my 7 to make 8 3 6. So let me go back for a second. 8 3 6. Before we move on, and before I move on to the next problem, I want to know, can I simplify 8 3 6? So it's time for another simplified check. Let's check and see.
I'm now checking to see if I can simplify or reduce 8 3 6 any further. Well, to do this, I need to find the greatest common factor of 3 and 6. I'm first going to list my factors for 3, which are 1 and 3. Next, I'm going to list my factors for 6, which are 1 and 6, 2 and 3. I know that 1 times 6 is 6, and 2 times 3 is also 6. Now is my time to find common factors. 1 is always a common factor, but I also have 3. So in this case, my greatest common factor, or GCF, would be 3. Looking back at my problem, I now need to divide my numerator and my denominator by 3. 3 divided by 3 is 1. And 6 divided by 3 is 2. So I know that 3/6 can be reduced into 1/2. So my final answer for this problem would be 8 1/2.
All right, our last problem, it says a baker buys a 5-pound bag of sugar. She uses 1 2/3 of a pound to make some muffins and 2 3/4 of a pound to make a cake. How much sugar does she have left? All right, again, I want to make a tape diagram for this problem. I know that altogether she bought a bag of sugar for a 5-pound bag of sugar, rather. The baker bought a 5-pound bag of sugar. So when I make my tape diagram, I want to make sure that this entire bar represents 5 pounds because that's how much the bag of sugar that she bought was. So go ahead and on your paper or on your dry erase board, make your bar, make your tape diagram, and we know that the whole thing represents 5 pounds. Now, although she bought a bag that was 5 pounds, she used some of that sugar. She used 1 2/3 to make some muffins. She used 2 3/4 to make a cake. And we're trying to figure out how much sugar she will have left. So here you'll see on my tape diagram, I represented this first section as the muffins, 1 2/3. The second section is how much sugar she used for the cake, 2 3/4. And this part down here is what we are trying to figure out. How much sugar does she have left out of her 5-pound bag? Now, there's a few different ways that you could solve this problem. Just like the others, there's different ways that you could solve it. One way that we could do this is we can add 1 2/3 plus 2 3/4 together first to figure out how much sugar she has used with both the muffins and the cake. To do that, I need to add 1 2/3 plus 2 3/4 together. Now, I can't just zoom and add straight across because my denominators are not the same. So I need to make them the same first. What is my least common multiple of 3 and 4? Well, I know that I have 3, call them out with me, 6, 9, and 12. And for 4, I have 4, 8, and 12. I found it. The least common multiple between 3 and 4 is 12. So I know that my common denominator, my least common denominator for these two fractions, 2/3 and 3/4, is going to be 12. So to do that, what can I multiply 3 by to get to 12? 4, and whatever I do to the bottom, I have to do to the top. So I know that 1 2/3 is equivalent to 1 8/12. Whereas this fraction, I need to multiply it by 3 to get to 12. So 4 times 3 is 12, 3 times 3 is 9. So 2 3/4 is equivalent to 2 9/12. Now that both of my denominators are the same, now I know I can add these two fractions together. And when I do that, I know that 1 plus 2 is 3. So my whole number is going to be 3 as of right now. 8/12 plus 9/12 is 17/12. I know that my denominators stay the same when adding fractions, and 8 plus 9 is 17. So I have 3 and 17/12. Now, I have another improper fraction, and I want to turn this into a mixed number. I know that I can rename 17/12 as 12/12 and 5/12. That 12/12 I could add to the 3 to make 4, and I have 4 and 5/12. So now I know that the baker used 4 and 5/12 of a pound of sugar to make both the muffins and the cake. She had a 5-pound bag, so how much is left? How much sugar does she have left? So now I'm going to take that 4 and 5/12, and what do I need to do? If you said subtract, you're right. I need to take 4/12 and subtract that from 5 to figure out how much is left in that bag. Now, I set this one up like a regular subtraction problem. I have 5 12s, but I don't see any 12s here that I can take this 5 12s from. So just like with regular subtraction of whole numbers or subtraction of decimals, I can rename that 5 as 4 and 12 12s, because I know that 4 plus these 12 12s, which is equal to 1, so 4 plus 1 is 5. So I can rename that 5 as 4 and 12 12s. Now I can take 5 12s away from 12 12s, and I can get 7 12s. 4 minus 4 is 0. So it looks like my answer is 7 12s, but I can't move on yet because I need to do a simplified check. Can I simplify 7 12s any further? Let's find out together.
I'm now checking to see if I can simplify or reduce 5 12s any further. To do that, I need to first find the greatest common factor of 5 and 12. I'm going to start by listing my factors for 5, which are 1 and 5. Then I'm going to list my factors for 12, which include 1 and 12, 2 and 6, and 3 and 4. Now I'm looking for common factors, and in this case, again, my only common factor is 1, which means this fraction cannot be reduced or simplified.
All right, 5th graders, it's time for your practice set. Practice these 4 problems on your own. The first problem reads, Cindy's drive to work is 1/2 of an hour, whereas Rob's is 1/4 of an hour. How much longer is Cindy's drive than Rob's? Number 2, on Monday, Kaya practiced guitar for 2/3 of 1 hour. When she finished, she practiced piano for 3/4 of 1 hour. How much time did Kaya spend practicing instruments on Monday? The next problem, Ruth had 2 1/4 cartons of cookie dough ice cream, 3 1/2 cartons of Rocky Road ice cream, and 2 3/4 cartons of strawberry ice cream. How much ice cream did Ruth have in all? And the last problem, Leslie has 1 liter of milk in her refrigerator to drink today. She drank 1/2 liter of milk for breakfast and 2/5 liter of milk for dinner. How much of a liter of milk does Leslie have left to drink with her dessert? Pause the video here and solve these 4 problems. Press play when you are ready to check your answers. Your answer to problem 1 was 1/4. And if you put that in a sentence, one example could be, Cindy's drive is 1/4 of an hour longer than Rob's. Your answer to problem 2 was 1 5 12. And if you put that in a sentence, one example could be, Kaya spent 1 5 12 of 1 hour practicing instruments. Your answer to problem 3, you may have first gotten 8 2/4, which you could simplify, and it would become 8 1/2. If you put it in a sentence, one example could be, Ruth had 8 1/2 cartons of ice cream in all. Your answer to problem 4 was 1/10. And if you put that in a sentence, one example could be, Ruth had 1/10 of a liter of milk left to drink. Great job today, 5th graders. I hope you enjoyed today's lesson, and most importantly, I hope that you have a better understanding of how to use the standard algorithm when working with adding and subtracting fractions and word problems. I'll see you guys next time. Bye, everybody.